Hello everyone, let us discuss some more examples to find the Laplace transform of the periodic functions. Today the first example is find the Laplace transform of periodic function defined by f of t, which is equal to kt divided by k into small t divided by capital T. We know that the capital T is a period here where our t is lies between 0 and capital T, and f of t is f of t plus capital T is equal to f of t. We know the result here. Laplace transform of f of t is equal to 1 divided by 1 minus e raised to minus st into integration from 0 to t capital T e raised to minus st f of t dt. Here limits are same because our t is varies from 0 to t. So 0 to t as it is, limits as it is. In the previous example, t lies between 0 and 2 means value of capital T is 2. Therefore, we have to replace t is equal to 2 in that example, but here t is remains same. So limits are same here. Then 1 divided by 1 minus e raised to minus st integration from 0 to t e raised to minus st f of t is k into t divided by t into dt. Here k and t are constant, so take outside the integration. K divided by capital T into 1 minus e raised to minus st, remaining is 0 to t e raised to minus st t dt. Next, to solve this integral, just apply the Bernoulli's rule. We get Laplace transform of f of t is equal to k divided by t into 1 minus e raised to minus st as it is. Here t as a differentiating part and e raised to minus t as an integrating part. So keep differentiating part as it is. Different integration of e raised to minus st is e raised to minus st divided by minus s minus, here differentiation of this t is 1. Again integrate this one, e raised to minus st divided by minus s is already there. Again it is minus s into minus s, limits from 0 to t. This can be written as k divided by t into 1 minus e raised to minus st, and this is t into e raised to minus st divided by minus s, here it is minus e raised to minus st, minus into minus plus s square, limits from 0 to t. Now we have to apply the limits. We get, which is equal to k divided by t into 1 minus e raised to minus st as it is. First we have to apply the upper limit. We get t e raised to minus st divided by s, it is minus t into e raised to minus st divided by s. Upper limit is 0. So lower limit is 0 because t value is 0 means 0 into something is 0. Next it will be minus, I will write here first for the upper limit, e raised to, sorry, here also we have to change the limit here, e raised to minus st divided by s square minus e raised to 0 is 1 divided by s square, 1 divided by s square. Then we have Laplace transform of f of t is k divided by t into 1 minus e raised to minus st into minus t e raised to minus st divided by s minus e raised to minus st divided by s square, then minus into minus plus 1 divided by s square. Now multiply term by term, we get minus t k e raised to minus s into t divided by t into 1 minus e raised to minus st minus e raised k into e raised to minus st divided by t into 1 minus e raised to minus st. Then k divided by s square into, here I have left the term s square, so s square into t, this is s square into t into 1 minus e raised to minus st. Now here t get cancelled, we get minus k e raised to minus st divided by 1 minus s into, because here s is there, s into 1 minus e raised to minus st. Now see here in these two terms k is common, this minus k is outside, this is e raised to minus st plus 1 it will be minus, because minus k into e raised to minus st, when we multiply this we get plus here, so that minus into minus plus, this is 1 divided by s square t 1 minus e raised to minus st. See here in the numerator e raised to minus st is there, e raised to minus st minus 1, here 1 minus e raised to minus st. I will change this term same as like this, so that minus k e raised to minus st divided by s into 1 minus e raised to minus st. Here to change this one, this will be plus k into 1 minus e raised to minus st divided by s square into t 1 minus e raised to minus st. Then this term will be cancelled. See here k into e raised to minus st value is in negative. See here also we get plus, here it is k minus plus into minus k into e raised to minus st is again minus k into e raised to xt, when it is k plus, here it is plus into plus k into 1 is again it is 1. Therefore we get minus k e raised to minus st divided by s into 1 minus e raised to minus st plus k divided by s square t. This is the required L of f of t. Next example. Next, find the Laplace transform of the full wave rectifier f of t is equal to e sin omega t, where t lies between 0 and pi by omega, having a period pi by omega. Means having a period pi by omega means the value of capital T is pi by omega. Here we have this result. Next we have to substitute the given condition here. Laplace transform of f of t is equal to 1 divided by 1 minus e raised to minus st, integration from 0 to pi by w. Here also we have to change this as pi by w, e raised to minus st e sin omega t into dt. Here e is constant, take outside the integration, we get L of f of t is equal to e divided by 1 minus e raised to minus s pi by w, integration from 0 to pi by omega e raised to minus st sin omega t dt. We have a standard result for this integral, that is integration e raised to ax sin bx, this is bx, dx is equal to e raised to ax divided by a square plus b square into a sin bx minus b cos bx plus c. We have to use this result for this integral. We get Laplace transform of f of t is equal to e divided by 1 minus e raised to minus pi s divided by omega as it is. For this one we have e raised to minus st divided by a value is minus s, b value is omega here, minus s square is s square plus omega square, and minus s sin omega t minus omega cos omega t, limits from 0 to pi by omega. Now s square plus omega square is constant, take outside from the limits. We have e divided by 1 minus e raised to minus s divided by omega into s square plus omega square e raised to minus st, and this term is as it is, limits from 0 to pi by omega. Now this term, first term is as it is, 1 minus e raised to pi s by omega s square plus omega square. Now first we have to substitute the upper limit, e raised to minus s pi by omega, and e raised s into sin omega into pi by omega. Omega get cancelled, sin pi value is 0, and this is minus omega into cos omega into pi by omega. Omega get cancelled, cos pi value is minus 1, therefore minus into minus omega is plus omega, therefore it is into omega, minus lower limit e raised to 0 value is 1, sin 0 is 0, something into 0 is 0, and cos 0 is 1, 1 into minus omega, therefore it is simply minus of minus omega. Okay, now we have e divided by 1 minus e raised to minus pi s by omega s square plus omega square e raised to minus s pi by omega into omega plus omega. In these two terms omega is common, take outside, we get e omega into 1 plus or e raised to minus pi s by omega plus 1 or 1 plus e raised to pi s by omega divided by denominator term is as it is, e raised to minus pi s by omega s square plus omega square. Now next is multiplying both the numerator and the denominator by e raised to pi u s divided by 2 omega in RHS. The expression assumes the form, means we have to multiply numerator and denominator to e raised to pi s divided by 2 omega. We get the expression is Laplace transform of f of t is equal to e omega divided by s square plus omega square. S square plus omega square term I will write first. See here, when we multiply, otherwise I will write one extra step here, s divided by w. We have to multiply this to e raised to pi s divided by 2 omega, and here it is 1 minus e raised to minus pi s by omega, multiply this to e raised to pi s divided by 2 omega. We get e omega divided by s square plus omega square as it is. When we multiply this one, we get e raised to pi s divided by 2 omega plus e raised to minus pi s divided by 2 omega. Here e raised to pi s divided by 2 omega minus e raised to minus pi s divided by 2 omega. To find this value, just e raised to, here bases are same, just add the powers, you get e raised to minus pi s divided by 2 omega, because minus pi s by omega plus pi s by 2 omega, when we take the LCM and simplifying, we get e raised to minus pi s divided by 2 omega. Similarly for this one here, this is simply pi s divided by 2 omega. Now we know the results here, hyperbolic results, that is first one is cos h at is equal to e raised to at plus e raised to minus at divided by 2, and sin h at is equal to e raised to at minus e raised to minus at divided by 2. We have to use these results here. We know that, see here, a value is same and at is same here, and you have to use this result. We get Laplace transform of f of t is equal to e raised to at e raised to minus e raised to at plus e raised to minus at is there. So we have to take e omega, we have to take this 2 on this side, we get 2 cos h at is pi s divided by 2 omega, and here it is s square plus omega square, e raised to at minus e raised to at is there, so it will be 2 sine hyperbolic pi s divided by 2 omega. Therefore cos by sine is cot, we get e omega divided by s square plus omega square as it is. It will be 2 get cancelled, cot pi s divided by 2 omega. This is the required Laplace transform for the given function f of t. Laplace transform of full wave rectifier, that is f of t is equal to e sin omega t. For the period pi by omega is e omega divided by s square plus omega square, cot of pi s divided by 2 omega.